raw materials that we are talking of, it is essentially the limestone, in addition to ordinary cement, Portland cement clinker that we produce, plus the clay. Now, the kind of clay that is likely to be used in this cement is kaolinite clay. So, we have places where we have actually cement factories already existing, and they are possibly getting because we produce around nearly 70% of our cement comes from what we call a material pozzolana, which add to the ordinary Portland cement. Now, the 30% still is the ordinary Portland cement clinker, and some of the pozzolana cement plants, they get their pozzolana from a very long distance place. So, also the kind of road network that's, in some places it is yet to develop in a big way. So, if they can get local clay and use it with the OPC clinker and local limestone with the OPC clinker, local clay to calcine them, kaolinite clay, suitable clay, and make this cement, this will have a big impact. So, there are additional production capacity, because we are already producing a huge amount of Portland pozzolana cement and Portland slag cement. We are going to investigate onto the whole thing. That's what it is. Also, it is important that we basically kind of disseminate whatever the finding is, or educate people about it, and convince the cement industry, because finally they are the one who are going to produce it, and also convince the user, who are not necessarily concrete technologists, like largely it will be structural engineers, and who understand certain language. So, first you have to establish, and you have to talk in terms of the manufacturer's language, because they would see their economics and the cost benefit. Energy consumption is very important. In a cement plant, you use fossil fuel which in the raw feed, right? And clinker is the one which requires that. Here also you will use some amount of fossil fuel for calcination, but you have to see the total energy, embodied energy as we call it, right from the transportation, production, transportation, everything put together. So, if that is actually reducing down, in addition to the carbon reduction, and the visible cost reduction is there for the industry will take it. They'll have to see. For example, I can give you an Indian scenario. I come from a place in the northeastern part of India, and there are a large number of cement factories because limestone is available. But then there are no thermal power plant. Now, they get the thermal ash for the Portland pozzolana cement. They get the ash from another state. We call it West Bengal, from Meghalaya, Assam. They get it from West Bengal actually. Now, which is the distance wise, it will be about good 800, 900 kilometers, and you have a single track lane, okay, not electrified, diesel pulled, because we use it's all diesel or electrically operated railway engines. So, the fly ash is carried that much distance to produce the Portland pozzolana cement. Now, if one can identify, limestones are available, suitable limestone which you can add, and kaolinite clay source, if you are able to identify in the vicinity of those cement plants, they would be very happy to use that rather than getting the fly ash from that kind of a distance. When we produce cement clinker, this ordinary Portland cement clinker, which has been there for last more than 1824 or something, so the 200 years it's there. Now, this cement, when you produce, we actually have limestone and clay together. I mean, basically limestone may have appropriate impurity. So, you have lime and clay, they should go together, and then you mix it up with the fossil fuel in the raw feed, and then you heat it up, right, for formation of a solid solution called clinker. Finally it melts into a kind of fuses into a sort of a material, we call it clinker, which is then grinded together with gypsum to get the ordinary Portland cement. Now, you see, you are first adding the fossil fuel for the process of burning, and when you heat up the limestone, it also generates carbon dioxide, because limestone is chemically calcium carbonate. So, this two process actually makes carbon dioxide, and the energy used up is also coming from the fossil fuel. So, that is how the contribution. So, this carbon dioxide is about 5 to 10% of the total anthropogenic carbon dioxide we release to the atmosphere. That is all coming from the, most of it is coming from the fossil fuel. Second one is the ordinary Portland cement clinker. But the point is, the reason why it's a very, it's 5 to 10%, because the quantity of cement we use in the world is huge. It's a material which is used by the human being next to water. So, you see, the quantum is very large. So, therefore, even a small reduction can mean a lot, particularly like country like India, which is using a lot of cement. So, it could mean a lot.